Hi there, I'm here to demonstrate that my elevator works. Um, so I'm just gonna get into it. So we're just basically supposed to show these things in the video. So our two use case scenarios, which differ based on allocation strategy, and the five safety scenarios. So the uh, the use case scenarios per allocation strategy just follow this simple path. One passenger goes from the bottom to the top floor. One passenger goes from the top floor to the bottom, and then one passenger goes from the middle floor to the top floor. So that's how we'll be formatting our simulations. Okay, so really quickly, just go over my allocation strategies. My first one's an idle one. It just checks to see if there's any of them are idle based on this variable moving. If they're not, it will just return it, whatever cart, which one it is. And the second one is a best candidate. It's a bit more complicated. It just checks if the request was in the same direction as the cart, then it returns that cart. And if it's the case that neither cart is in the direction of where a request came from, then it'll just send whichever one is the less heavy cart. So those are the two allocation strategies. They both tend to favor the first cart a bit more because that's just how the if statements branch out. So they could both be going in the same direction as you can see here, but it'll return one first before it returns two, just how it works. So yeah, that's just FYI. So really quickly, let's test the idle allocation strategy. So the way I do that is I just space them out and I time them out so we never get more than two requests at a time. So I wait for an elevator to stop its path and to go idle again. So basically, I send. Also, FYI, I have a ground floor, so I do have five floors, even though my highest floor is floor four. It just because I have a ground floor. So the first request will be from the ground floor and end at the top floor, and cart one will go for that. The second request will be from the bottom, from the highest floor, and it'll go to the ground floor, and that's what cart two will do. And then we'll have a queue timer to just wait until cart one to be done, because cart one will be done before this one, because this is a longer path, because they both start at the bottom floor. So you can imagine this has to go all the way up and then down. This one just has to go down, all the way up, and then it'll stop. So we wait on it. We wait for cart one to be done. It'll be done first, and then once it's idle again, it'll call it and it'll pick up the guy from the middle floor and send him to the top floor. And yeah, these are the passengers, and it's testing the idle strategy. So let me just throw that up really quickly. So he picks up the guy from bottom floor, drops him off. It's done, and then it restarts. Picks up middle guy and drops him off at the top floor. He picks up the middle floor person and drops him to the top floor. This one does is go to the top floor, pick him up, and then drops him off back at the ground floor. So this one takes longer. So yeah, you can imagine why this one picks him the other guy up first. Uh, yeah. Sorry. No, I'm just making something right now, really quick. Oh, I'm sorry. That's my mom calling me for food. I can't cut the video though. I've recorded this like 10 times and my voice is so tired. So I'm just gonna continue. Um, so yeah. Anyways, you'll see bell rings and stuff whenever it comes to a requested floor, and you can see the data. Not the data, but the displays updating. It shows like where the passenger currently is. Anyways, that's idle. That's the idle strategy. This one's a bit more complicated. So essentially at the top, what I did here was I set those both to be moving, so the idle strategy doesn't get called and best candidate gets called instead. So again, we're following the same path as before, except I'm just putting it all on one elevator just to show that multiple requests on a single cart can work. And this is a much more faster way and efficient way. So if you want to look at the strategy, what's really happening is it's constantly just falling into this first if statement. So uh, it checks cart one, it checks the number floor, it sees that it's in the direction where cart one's currently, because technically cart one always starts in the up direction because it starts at the ground floor anyways. So yeah, so they're all funneling into cart one, but we'll test the rest of them later. the rest of the branching statements. But anyways, let me just show you that this works. So you see sim 2, it does a second, it does the path we saw before, but just way more efficient. So it picks up the ground floor person, picks up the middle floor person, it drops them both off at the top, picks up the top floor person, and then releases him at the bottom. So yeah, much more faster, much more nicer. Now, let us test. So now we're going to set the cart 1 to look in the opposite way. So logically speaking, now cart 2 should be picked because cart 1's not going to be in the same direction as the requests. So now cart 2 should be picked. So here, let us test that. So it should follow the same path, except just cart 2 is now being picked instead because cart 1 is looking the opposite way. So yeah. Yeah, you could, it's exact same path as prior. Awesome. But now I want to test it based on the weight. I'm just trying to test like all the, like, I guess the branching statements as thoroughly as possible. So now we're going to set them both to be looking downwards, so not in the direction of the requests. And what should happen is, oh yeah, we're also going to set cart 1 to have a heavier weight. So because all these requests are happening at the same time, at the time of requests, cart 2 will have a lesser weight, so all these requests will be put on cart 2. So again, it should be the same path. However, right at the start, you'll see that cart 1's weight goes straight to 100. This guy's still at 0, so he's going to be picked. And yeah, so cart 2 is going to get everything. So yeah, 100, he's lesser, so he's going to pick up all the requests. Yeah, it's the same path as before. Okay, awesome. So lastly, I will test my safety scenarios. These are a bit more simple. Um, so yeah, let's just go over those really quickly. Uh, I'll probably use simulation 1 for my safety scenarios because both carts are running at the same time, so it's probably the best way to test it. Except overload, that's a bit different, and the open close. But anyways, so we're going to test power outage. What it should do, power outage, fire, and help kind of work the same. They all print like a message specific to whatever's going on. Power outage, fire, helps on the way, send you to the ground floor. So they all print a message, they all send you to the ground floor. They all have some sort of audio bell ring to let you know something's going on. Anyways, so yeah. So by the way, if there's any passengers in it, so I'll run it right now. So yeah, power outage in process, and it's all sending you now to the ground floor. If So in this case, we did pick up a passenger, so we did remap the route, and he was normally supposed to get dropped at the top floor, but now we drop him instead at the bottom floor. In this case, if there's no passenger, as we see in cart 2, there's no passenger, so yeah, nothing happens. We just send the thing to the bottom floor. And we also cancel any requests, as you can imagine. Yeah, so we'll run a fire this time. I guess we could just wait a bit more. See. Okay, now they both have passengers, hopefully. Okay, well, this one didn't have passengers, so I timed that wrong. But anyways, it's the same deal. I could time it when that guy has passengers, if you want to see that. So I'll wait till cart 2 gets a passenger to show you. Okay, so now he has a passenger, so I'm just gonna. So it's gonna get rerouted straight away and send him straight to the ground floor, and they're both at the ground floor. Yeah, so that's fire alarm. It's pretty simple. Help also works the same way, except help's a bit more. It is. It's more specific, so I'm not gonna like obviously in a power outage and a fire you send both elevators to the ground floor, but in a help you'd only send the specific elevator that needs help. So if I say help, I guess on elevator 2, I suppose, uh, there's a passenger in it, so it will be dropped off at the bottom floor, and yeah, that's really it. So help is just specific to the is basically like the others but specific to elevator. This elevator is in the 4th floor, Nobody's in it, so logically you couldn't really click help, but yeah, assuming you did. Um, yeah, all it does is just take you to the bottom floor. It says contacting safety first services. There's a bell ring. It's kind of similar to the others. I guess the more unique one is overload. Uh, if you look at the code for overload, you'll see that my elevator max is at 300 kilograms. So if you go to overload, yeah, what it does is it just makes a passenger that's super heavy, and it requests an elevator to pass. This passenger requests an elevator at floor 4. However, you'll see the elevator just like it's like, sorry, we can't accept you. So yeah, so we're at ground floor. We go all the way to floor 4 because we've been requested. We say we can't add the passengers, so we don't add them in the wait, and we don't even take their stop, so it just gets canceled. So yeah. Um, oh yeah, and the doors. Yeah. So the doors could be used we uh, when we're idle. It's quite simple how the error comes up. If you just continuously mash open door, it'll tell you to stop, and if you click any more, it'll be angry. You have to click close the door before you can open it again. So yeah, so you have to close it. So that's just it. The door isn't really special, but yeah. Anyways, I think I've went over everything. Let me just check. Yeah, I think I went over everything. Thanks for watching. Yeah, thanks for your time.